Okay, so in the previous video, we looked at how do we divide two polynomials and using long division, and we ended with looking at two situations where we had a remainder of 0 and a remainder of something that was non-zero. And we are going to find here that there is some interesting facts that can be said in the two situations. So the first, let's examine what's called the remainder theorem. So the remainder theorem says this: if the remainder is non-zero, so that could be any other number other than 0. If the remainder is non-zero when f of x is divided by, let's say, just in general, x minus k. What can be said then is that when we take this k value, this number, into our function, what we know that we will get is what the remainder is. So that might not make sense right now, so we're going to see that in a little bit. But most importantly, what we know, and what this kind of is crucial, is what can be said in this case when the remainder is non-zero, is that this x minus k is not a factor of f of x. And that's kind of our end goal, is to get a polynomial into factored form. So this will tell us if something is or is not a polynomial. So we had this situation in the previous video. 3x cubed plus 5x squared plus 8x plus 7. We divided that polynomial by 3x plus 2. And we saw that we get a quotient of x squared plus x plus 2. And we had a remainder of 3 out of the x plus 2. So because we have a non-zero remainder, what we say then is that when I take, say, 3x plus, whenever we set that equal to 0, we get, our k in this situation would be negative 2 over 3. So what we can say is when I place this value into the function, we know that we should get 3 as a result. So let's write this down. So we place our value in, and we will get our remainder. And that's just in general with any of these. When you place the k value into your function, you will get your remainder. So we do this, and you can do this in your calculator, but in short, you can pause the video and check this if you don't believe me, because I was a little doubtful at first. But if we put this into the calculator, we will find that from all of this, we get simply 3. And that's what we're saying here, is when our remainder is non-zero, we take our k from the divisor, place it into the function, and we get the remainder out. So that is the remainder theorem. Then we have something called the factor theorem. So the factor theorem says, kind of a similar story, if the remainder is 0 when f of x is divided by x minus k. If our remainder is 0, then as a result, and we said this before, whatever k is will equal the remainder. Well, the remainder was 0. Okay? But with that, we also can say, we saw this when we looked at solutions, zeros, roots, x-intercepts, all of those terms that are interconnected. When a value makes a function equal to 0, what we can call this value is a0. So if k is a 0, then this factor x minus k is in fact a factor of f of x. So these two are the main concepts that we want to think about throughout this video, is what we're getting as the remainder. So let's say we have this kind of alternate question. Find the remainder. When f of x, the function here is x cubed minus 3x squared minus 22x plus 24 is divided by these three possibilities. So let's divide this function first by x minus 2. So what we are saying in the remainder theorem is we can take the k here, the k would be positive 2. We can take k, place it into the function, and what we get as a result will be the remainder when we divide by this factor. So you can do this yourself. You should find that the remainder is negative 24. So we're going to talk about what else we can say. Let's look at another example. So let's say we divide by x minus 6. So again, our k would be positive 6. Place positive 6 into our function. Doing the work, doing the calculation, we find that we get 0. Okay. So then let's take our function one more time and divide our function by x minus 4. So we place our k into our function, k of 4. And in doing so, we find that we get negative 48. So thinking about all of that, and thinking about the remainder theorem and the factor theorem, what can be said about one of these factors? What we should be able to say is, since k of 6 gave us a result of 0, that is the remainder of 0, what we can say about this factor, k minus 6, it is a factor of this polynomial. Meaning, I can separate this cubic function having x minus 6 multiplied by other factors, where the others cannot. So we have the remainder theorem and the factor theorem. So let's apply this to a couple more examples. So let's see. If we take x plus 1 and divide this by x cubed minus 5x squared plus 3x minus 2. Now, I encourage you, pause, divide through. We want to focus on the remainder. And I ask you, when you find the remainder, what will this remainder tell us about x plus 1? So then, also, after doing that, I challenge you to also solve x minus 6, x cubed minus 3x squared minus 22x plus 24. And I believe we should already know what's going to happen in this problem because of what we found in this situation. we found that x minus 6 does in fact give us a remainder of 0. So we will see that we can write x cubed minus 3x squared minus 22x plus 24. We can write this function as x minus 6 multiplied by some other polynomial, I believe it's going to be a quadratic, with no remainder needed. So post your questions, post your comments, and rewatch this video as many times as you need to, and we're going to continue practicing this skill and building on this idea of dividing and looking at understanding when a polynomial is a factor of another through dividing.